In this video, we want to find the limit as x approaches 0 of tangent of x raised to the sine of x power. So notice here, if I plug in 0, I get 0 raised to the 0 power. And this is an indeterminate form. So I want to get it so that I can use L'Hopital's rule. So basically, can I bring down the exponent and get in a situation of, let's say, 0 over 0 or infinity over infinity? So one thing at a time, I want to bring down the 0 and then maybe do some algebra and get it in these two forms, either of these two forms. So let's first focus on bringing down the exponent by taking the log of it. And so what we're going to do is use the fact that e to the natural log of x is equal to x. X here is going to be this tangent of x raised to the sine of x power. And now we know that the natural log brings the exponent in front, the exponent here being sine of x. So this guy comes in front of the natural log. Okay, and so at this point, I'm going to bring the limit as part of the exponent. So basically, e and the limit here are going to switch spots. So the focus is going to be on the exponent. And so at this point, sine of x goes to 0. So if we're just focusing on the exponent, forget e for a second, this goes to 0. And as tangent of x also goes to 0, let's say if we're approaching it from the right, natural log of tangent of x will approach positive infinity. If it was approaching it from the left, it would be negative. So I'm just going to put plus or minus. It doesn't really matter what the sign is. But the point is that it's 0 times an infinity. And the goal is to get it into either 0 over 0 or infinity over infinity. And the trick is, you're either going to write natural log of tangent of x and then all over 1 over sine of x, or sine of x over 1 over ln of tangent of x. Okay, so that's the way we're going to handle it. So the question is, should we put sine on the bottom or should we put natural log of tangent of x? Well, you should always do what's easier, and typically, taking the derivative natural log of something can be a little weird, like when it's 1 over a natural log. So why don't we choose the first method and just rewrite it as 1 over sine of x, because now this is going basically plus or minus infinity over, I guess in that case it's still plus or minus infinity, because it depends if you're approaching it from left or right. So it's infinity over infinity, where in this case, now we can use L'Hopital's rule. So take the derivative natural log of tangent of x to get secant squared over tangent of x. Take the derivative 1 over sine of x. That's negative cosine x over sine squared x. And so here this simplifies to negative tangent squared over cosine times tangent of x. And the way this works, so I guess I did skip a couple steps. So here the sine squared is going to multiply the secant squared. So we have sine squared times secant squared. And then these two guys are going to multiply. I'm going to factor out the negative here. And then we have tangent of x times cosine x. Now this secant squared, I'm just going to write it as 1 over cosine squared. So I have sine squared times 1 over cosine squared. That's the same thing as sine squared over cosine squared, which is negative tangent squared. And on the bottom, I'm going to switch spots. I'm going to put cosine first and then tangent second, because that's what I did over here. Okay. Now I can cancel out one of the tangents. So I have negative tangent over cosine, which if I plug in x equals 0, the numerator becomes 0 over 1, which is 0. So then we have e to the 0, which is 1. And so that is our limit.